Guys, and welcome back. So this is day 3 of Unit 2. So we've just done some work with linear functions and learning how they work and learning that it doesn't have to come from a pattern, that we can go from just a couple of points and write our equations. So now we're going to look at doing that without a table, and we're going to use what we call point slope formula. And it's going to be very similar to our explicit formula that we talked about in Unit 1. So the formula for point slope is that we use y equals m times x minus x1 plus y1. So we will, so that is your point slope form. And then if you want to put it into slope intercept form, you just distribute and solve for y. So let's put that underneath. So the one connection I want to make is point slope to our explicit form from arithmetic sequences. So if we think back to the arithmetic explicit form, we would have had that f of n is equal to whatever our first term was plus d, and we would do that n minus 1 times because we have our first term. And then thinking to point slope form, so what I just showed you of y equals m times x minus x1 plus y1. The things we're going to change are the x1, the y1, and the m. Everything else is this shell that we're using. And so what ends up happening is we've talked about the m being the d, so that comes from right there. And then this just tells us the term number, which is our x value. So these pieces are the same. And then this is the term, which would be the y. So the arithmetic explicit form and point slope form are really the same. So we want to think about this as how far we are from 0, and this is what we get when we're there. So thinking about the x1 as the term number in relation to 0 and the y1 as the actual term. And that should help you. So a couple of other things to note. You do want to make sure that you change, when you're plugging into your equation, change the sign of x. And you will keep the sign of y. And again, we will only simplify if we are putting our equation into slope intercept form. So let's do a few examples. On these examples, for the odds, we're going to leave them in point slope form, and the evens, we're going to simplify to slope intercept form. So looking at number 1, we have 4,1 is the point, and then it has a slope of 2. So what you're going to do is you're going to plug into your point slope form. So you're going to have y is equal to, and then remember that this is x, this is x1, this is y1, and this is m. So you're going to plug into your equation. So everywhere you see x1, you put x1, which is 4. Where you see y1, you'll put 1. And where you see m, you'll put 2. So we're going to have y is equal to m, which is 2, times x minus our x1, which is 4, and then plus y1, which is 1. And then that is point slope form. So you are done. Let's look at number 3. We're going to do all of the odds first. So once again, I'm going to rewrite my formula here. So we have y equals m times x minus x1 plus y1. So I'm going to label my parts. -6 is x1, 0 is y1, and my slope is m. So then I just put everything where it belongs. So y will be equal to 2/3, then the parentheses, x minus -6 plus 0. Remember we talked in Unit 0 about the negative, that double negative really makes a positive. So you could even write it as 2/3 times x plus 6. And then adding 0 is the same as not adding anything, so you could leave it just like that. I would accept either answer here, the simplified piece that we just boxed in, or the piece that we started with. You try and do number 5. You should have labeled the 4 as your x1, the -3 as your y1, and the -1 as your slope m, and then plugged it into the equation just like I wrote below. So you would have y equals -1 times x minus 4 minus 3, or you could just write negative. And so what we're really kind of getting at is that if you were to put this in a table, we could think of this 4, -3 as the 4th term. So there would be a term 3, 2, 1, and 0 before it. So we want to say -4 because that's how we get back to 0. So you want to think how far away from 0 you are. If your x is a positive, we have to go backwards to get to 0, so we want to minus it. If our x is negative, that means we're behind 0, so we have to add to get to 0. And that would be a way that you can think about it to help you relate it back to our function notation with our arithmetic sequences and writing the explicit formula. It's just how far we are away from that 0 term that helps us remember it. So now let's do the evens where we're going to put them in slope-intercept form. So the first steps are going to be the same. We are going to go ahead and label out that 2 is x1, 4 is y1, and our slope is m. Then we're going to go ahead and plug into our equation. So y is equal to 1/2 times x minus 2 plus 4. And then the next step is just going to be to distribute and get rid of your parentheses and then combine your like terms. So you're going to do 1/2 times x and 1/2 times -2. So we get y is equal to 1/2 x, and then 1/2 times -2 is -1, and then we just add 4. Remember, you can only jump one parentheses, you can't jump two parentheses. Then we combine our -1 and our 4 so that we get that y is equal to 1/2 x plus 3. So then we can see that our slope is still 1/2 and our y-intercept is 3. So we see our slope-intercept form. So let's go ahead and we kind of put that up here, but let's do some steps. So your steps to get into slope-intercept form will be to first distribute your slope into the x and the x1 value inside your parentheses. That gets rid of your parentheses. Then you can combine your like terms, which will leave you with a simplified expression, which is in slope-intercept form. So let's do another example. Let's look at number 4. Again, we are going to label -8 is x1, -1 is y1, and my slope is m. So plugging in, I get y is equal to -3/4 times x minus -8 minus 1. Thinking about this double negative would make it a positive, so I'm really having x plus 8. Distributing the -3/4 into both the x and the 8, I get that y is equal to -3/4x. -3 times 8 is -24, divided by 4 is -6. And then bringing down my -1. Combining my like terms, I see that I have -6 and -1, which brings me deeper into the negatives to -7. So my slope, again, is -3/4, which we saw from the beginning, with a y-intercept of -7. So we can see that our equation is y equals -3/4 x minus 7. You take a couple minutes and you do number 6 on your own. So you should have labeled out that 0 was x1 and -9 was y1 with a slope of 4. So when you plug in for point slope form, you would have y equals 4 times the product of x minus 0 minus 9. Distributing the 4 in, you get 4x minus 0 minus 9, and then combining your like terms, you get the 4x equal, or that y is equal to 4x minus 9. If you notice, 0, negative 9 is your y-intercept because your x value is 0. So your y-intercept always happens when x is 0. So you could even go straight to slope-intercept form from what you were given there because you're given the y-intercept. But as you can see, you can always plug through point slope form and end up with the same answer. So even if an equation or a problem asks you to write the answer in slope intercept form, you can always start with point slope form and then simplify to slope intercept form, causing you to only have to remember one equation instead of multiple. Tomorrow in class, we will work the rest of the examples in this note sheet, and I will answer any questions that you have. I will see you then.